Hey guys, Jake here coming at you with another math lesson today. Today we're going to continue our discussion of the derivative of elementary functions from my book, The Elite Guide to AP Calculus AB. If you want to go get yourself a copy, you can scan that QR code in the upper right hand corner or check the link in the description or pinned comment below. But today we're going to continue discussing the derivative of elementary functions. Actually, I think today is going to wrap up that topic, and then we'll move on to a little bit some other stuff next. We're going today to be discussing the derivative of inverse trig functions. So, you can see these 6 functions up on the screen now: arcsine, arccosine, arccosecant, arcsecant, arctangent, arccotangent. We're going to be talking about how to remember those derivatives. I think for me personally, the hard part about these derivatives is more so remembering them, not as much about applying them, because I think once you kind of learn a lot of the other derivative tricks that we'll be going over in the coming days and weeks, actually applying these formulas, becomes a little bit easier using those other tools. So for actually discussing the derivative of these inverse trig functions, I want to really focus on how to remember them, because that to me is a big hurdle. It was for me when I was learning it, and I think it is for a lot of other people. So let's go ahead and dive right into it. So in yesterday's video, we talked about the derivative of trig functions. Now we're talking about the derivative of inverse trig functions. Some of the memorization tips that I talked about in that trig function video are actually going to be helpful for these inverse trig functions too. So I'm going to go through this a little bit quicker than I did those in yesterday's video, because I think for these inverse trig functions, it's more just kind of straight memorization. For trig functions, there's some kind of logicking I like to do personally. You could always just memorize them too, but I like to kind of think about the logic of it. I think it helps me just to kind of verify that I'm correct, rather than just relying on straight memorizing and hoping that I've remembered it correctly. But for these, I think it's going to be, thinking about the graph of any of these derivatives is quite a challenge. So I don't think that's particularly helpful for these functions. But let's talk about how to actually memorize these. So similar to yesterday's video, let's start by kind of grouping some of these functions and derivatives together. So first thing I want to point out, obviously they all are arc something, right? That just tells you that they're inverse of whatever. So arcsine is the inverse of sine. Arccosecant is the inverse of cosecant. But let's think about what the kind of, the function that we're thinking of the inverse of as our kind of way to memorize. So think about sine, cosine, cosecant, secant, tangent, cotangent. Similar to the trig function derivatives, with these, any that start with co, so in other words, cosecant, cosine, and cotangent, their derivative is going to be negative. And any that don't start with co, I'm not sure the best way to write that, but sine, secant, and tangent, their derivatives are positive. So if it starts with co, the derivative is going to be negative. If it doesn't start with co, the derivative is going to be positive. Okay, so that's the first thing you want to remember. Next, we can actually just kind of group these together just in terms of, I'm not sure the best way to kind of describe the grouping necessarily, but let's group together sine and cosine. So arcsine and arccosine, they're going to be a group together. We will also group together cosecant and secant. And then we will also group together tangent and cotangent. Those kind of groupings: sine and cosine, secant and cosecant, tangent and cotangent. Pretty much the way I can remember that, I guess, would just be, group them in twos based on what sounds the most like it. Sine, cosine, secant, cosecant, tangent, cotangent. Okay. The reason I say that is the derivatives of each of the two pairs that go together each of those two have the same derivative other than one is positive and one is negative. The one that starts with co is negative, the one that doesn't is positive. So look at the derivative of arcsine and arccosine, for example. You'll notice those two derivatives are exactly the same, just one is negative, one is positive. Same with cosecant and secant. Same derivative, except the cosecant one is negative, the secant one is positive. And then again, for arctan and arccotan, the derivatives are exactly the same, except the arccotan is negative, the arctan is positive. So you're really only having to remember 3 derivatives, and then just know that if the thing started with co, you make it negative. If it didn't, you don't. So that kind of helps simplify the memorization, right? There's only 3 things you have to remember. Okay. Next, let's talk about how to remember what those 3 derivatives are. So let's talk about arcsine first. Well, actually, before we do that, all of them, you can very clearly see, are 1 over something. Okay. So very simply, all of them have 1 over something. They're all going to be in that form generally. So let's start with arcsine. Arcsine is just going to be, frankly, for remembering the denominator, the only other kind of thing to point out, I think, is they're all going to have, x squared and 1 in them. It's just figuring out if it's x squared minus 1, 1 minus x squared plus 1. Those are really your options there. There's going to be an x squared and a 1, and you're going to either add or subtract them. Then it's just remembering kind of the order from there. The other thing to point out, the sine, cosecant, cosine, secant. So basically the sine and cosine ones, basically anything that doesn't involve tangent, that's going to have a square root. And your 1 and x squared terms are going to be within that square root. There's not really much else that I find helpful to kind of think about beyond that, other than just kind of remembering those general patterns. We have a square root in these first 4, no square root in the bottom one. So, you can kind of draw a line right here. Everything above that line looks a little more similar to each other. Everything below that line looks a little more similar to each other. The tangent and cotangent ones are going to be the simplest. And the reason why is the cotangent and the tangent one, it doesn't have a square root, so no square root for these. And it's x squared plus 1, or 1 plus x squared. The reason why that makes it easier is because the order there doesn't matter, right? 1 over 1 plus x squared is the same as 1 over x squared plus 1. So the tangent, cotangent have a plus on the denominator, which means you don't really need to worry about the order anymore. It has a plus and it doesn't have a square root. So that one is very straightforward. The ones that do have square roots and have, 1 minus something, 1 minus x squared, or x squared minus 1, there the order matters. So these, it kind of just becomes straight up memorizing. I don't think there's really a super good way personally that I like to use to kind of remember the order here. You kind of are going to just need to remember that the sine and the cosine ones are 1 minus x squared. So sine and cosine are the square root of 1 minus x squared. And then from there, just remember cosine is going to be negative, sine is going to be positive, because cosine starts with co and sine doesn't. Okay, and then for the secant and arcsecant, arcsecant and arccosecant, very similar, except now we're switching the order. So instead of 1 minus x squared, we're going to have x squared minus 1. And then we're just going to add an absolute value of x on the outside of the square root for secant and cosecant. And then again, co is going to be negative, secant is going to be positive. That's really all there is to it, I think. I know that, once you kind of get down to the order of which is which, it kind of becomes a little bit more challenging. But I would just remember sine cosine goes 1 minus x squared, secant cosecant goes x squared minus 1, and then you also have that absolute value x in the cosecant and secant. And then again, for tangent, it's 1 plus x squared, or x squared plus 1 on the denominator, no square root. All you have to worry about is the 1 over 1 plus x squared. For cotangent, it's negative. For tangent, it's positive. So that's pretty much what I do to remember those. I hope you found this video helpful. If you did, do me a huge favor, hit that thumbs up button, subscribe to the channel, be sure to check out the Elite Guide to AP Calculus AB, and I will see you next time. Thanks, guys.